Hello friends, today we are going to see the topic about integration. It is nearly linked to differentiation too. Okay, like differentiation, it also have a concept. Okay, the concept of integration is addition of areas. We use these to find especially the area under a curve. We mostly use to find the purpose. Okay, for better explanation I'm going to show it in a diagram. So I'm going to draw a graph. Here are my x and y axes. So after drawing the axis we have to name the axis, so y and x. So this is my graph. So the name is y is equal to function of x, and I wanted to know the area under these 2 points where x is equal to a and b. Okay, so for that I cannot find it straightly, so I'm going to divide it into n equal parts, where one part the width of a part is delta x. Okay, so it can be given in the form where area of a to b is equal to limit summation of I is equal to 1 to n, where f into xi into delta xi. So it can, when n tends to infinity, so it can be given in the form using the integration. So this is the sign of integration. From b to a we have to write the big amount in the upper. So function of x in with the respect of dx. Yes, here we know dx is also already we have learned. So after that we have to know about the link of differentiation and integration. So integration is the reverse process of differentiation. Likewise, for the integration we have the answer and we have to find the question. The question is integration and the answer is differentiation. Think it like me. So the product of differentiation is called as derivative. Likewise, the product of integration is called as integral. Next we are going to see the difference between differentiation and integration. Okay, we know if we write y is equal to x squared, the dy by dx is 2x. This is the differentiation. So we have to, this method we have already know that. So if we go to the integration part, we have given what is dy by dx. So for integration, dy by dx is 2x. So we have to find out what is y is equal. So that is this much, the link between differentiation and integration. Let's see some rules we use in integration. Okay, if you write integration of 2x with respect to dx, okay, just think from if we differentiate which number or which value, we will get 2x. Yeah, if we differentiate x squared with respect to x, we will get 2x. So the answer will be x squared Okay, and also think if we differentiate y is equal to x squared plus 3, also we will get 2x. No, sorry, if we differentiate this one, also we will get 2x. So when we do the integration, we put a constant here because we don't know whether it will have a constant or not. Okay, so with that, what we have done here, we are adding plus 1 with the power. See, if we integrate 2x with respect of dx, we are getting x squared plus c. No, so here what are we doing? We are adding the power 1 with the power and dividing it with adding 1. So we are getting the answer. So from that we can come to the first rule. When we integrate x to the power n with respect to dx, the answer will be x to the power n plus 1 divided by n plus 1 plus c. Okay, then we go about the other thing. If you see, this is the rule number 1. Rule number 2 is, if you integrate something like this, du over u, or integration of 1 over u with the respect of du. Okay, yes, we know if you want to get 1 over u, you have to differentiate ln u plus c. So this can be x also. So for that only, here this rule is not applicable for n is equal to minus 1. Only for this this part. So only for minus 1, this rule is not applicable. Rather than we can use any other n's. So here you have to consider that du over u. So the numerator will be the differentiation of the denominator. Then only we can use this rule. Okay, let's see about the last one, exponential functions. So we do the e to the power n into x with respect to dx. Okay, if we differentiate this, we know when we differentiate e to the power nx, there will be n into e to the power x. No, so we are having anything here, so e to the power nx, and it have to be divided by n, then only we will get the answer. Okay, with the integration, if you want to check the integration, just differentiate the answer and see whether it is coming here, then your answer is correct. Okay, we want to know, let's check. If we differentiate, okay, we are having the equation e to the power nx divided by n. So if we differentiate this, dy by dx, so n will be the constant, so it will come here. If we differentiate e to the power nx, so e to the power nx with n, so they will be cancelling out, and e to the power nx is here. So our answer is absolutely correct. Next we are going to see about indefinite and definite integral. Okay, let's go with an example for indefinite integral. Integration of 2x with respect to x. So we know the answer is x to the power 2 plus c. Okay, so where the c is a constant and we don't know the value of the c. So whenever we get the integration where the c and we don't know the value of c, it is the indefinite integral. Okay, let's move with definite integral. Yes, your guessing is correct. We will, in definite integration, we will get we will end up with a definite value. Okay, let's see with the same example where we are having the value of x between 2 points. We see at the beginning, we see between a and b. Like that we are getting the number. So integration, and we have to put the 2 points, and we will write the lower value in the low and the upper value in the above of this integration sign. So 2x with respect to dx. We know that we have to write the answer of 2x is x to the power 2 plus c, and we have to note that 2 points, 2 and 0. So if we just simply substitute those points, okay, x to the power 2 we have to write the numbers. So 2 to the power 2 plus c minus 0 to the power 2 plus c, where okay, in getting calculation c will be cancelled out, so we don't need to know about the value. So 4 minus 0 is equal to 4. So if we want to write, we can write without the c also. So that is also no mistake in definite integration. So we can write this as x to the power 2 from 2 to 0, 0 to 2. Okay, and if we are not getting c's here, we can write without these 2 c's in the substitution. Okay, let's write that from the another one equation. Okay, let's go the integration of 3x squared with respect to dx from 1 to 3. So okay, is equal to, we will go from the rule. So 3 is a constant, so it will be remain there, and x 2 plus 1 is 3 over 3, so both these are cancelled out, and we get x to the power 3 from 1 to 3. Then simply substitute 3 to the power 3 minus 1 to the power 3. So it is equal to 9 minus 1 is equal to 8. Okay, we are getting a finite value. Okay, what's this finite value? I'm drawing the graph of y is equal to x to the power 3, but I don't know whether I'm drawing the correct graph. For your better some explanation, so if the we have to know the area under this curve from 1 to 3. So this part is equal to 8. Okay. And if we want to know the unit, that depends on the x and y axes.